Hi guys, this is going to be the last video for the homework. We are going to look at questions 75, 77, and 79 for this worksheet, for this video. All right, write the condensed electron configurations for the following atoms using the appropriate noble gas core abbreviation. All right, so we can look at cesium. Cesium is here. If we go to the previous electron configuration, that would be xenon. So that would be Xe. So there's my core electrons because that's all encompassed in xenon. Now we can take a look at the periodic table. 1, 2, 3, 4, 5, 6. It's in the 6th row down, so it's going to be 6. It's in the S block. Remember, this is the S block. This is the P block. This is the D block. So it's in the S block, and it's in the first row of the S block. So that would be S1. So cesium would be xenon with 6S1. Now I can prove this to you by going through the alphabet chart that you're used to using. Okay, again, cesium is 55. So we want to count these little numbers up till you make 55. I'm going to change the color since that is in red. First thing we hit is 1s2. Next row is 2s2. From here, the first thing we hit is 2p6, then 3s2, then 3p6, and 4s2. Notice I'm going from the upper right to the lower left. So far, I have 10 here and 10 here. I have 20 electrons total. 3d10 is next. So that means I have 30 electrons at that point. 4p6, 5s2, 4d10, 5p6. Let's see where we are at this point. So that's 36 and 38. With those 10, it'd be 48. And then with this 6, it'd be 54, which means we only need one more electron, which gives us 6s1. Now, all of this is in xenon. That's the relationship between the abbreviated and the regular. Let's try another one. Part B is talking about nickel. Nickel is right here. It's number 28. The previous one is argon at number 18. So I could say is everything argon is plus, remember these start at 3. So even though this is 4s2, this is 3d because of the alphabet principle. So we're here. It has 4s2. And then 3D, 1, 2, 3, 4, 5, 6, 7, and 8. So 3D8. Let's confirm this with the long configuration. Again, we're trying to get to 28. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So let's see, we have 10, 20. We need 8 more. So that 3D, instead of saying 3D10, we're going to say 3D8 because that's all we need. Now, argon is 18. So we have 10, 12, plus another 6 is 18. This is argon. That's how that fits in there. All right, part C is selenium. Selenium is right here, number 34. Again, the closest up from it is 18. You can't go to 36 because that's too many. You need to go to 18. All right, so we're going to use argon again. Then from here, we're going to say 4s2. And then we're going to say 3d10. Next, we go back to 4, but we have 4p4. 1, 2, 3, 4. Let's confirm that again with our long version. Again, selenium is 34. So that means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. We have 10, 20, 30. We need 4 more. So that 4p6 becomes 4p4. You can go less than that number. You can't go over it. Again, argon is 18. So here's 10, 12, plus another 6 is 18. This here is your core electrons for argon. Now, just to throw this out there, I have seen some textbooks and some professors rearrange these to be in numerical order by their principal energy level. So I would not be shocked if I saw an answer that said this: 3d10, 4s2, 4p6, saying that these are the most outermost because they're in the next energy level out. So those are the true valence electrons. Only because if you're looking at the molecule, the atom, that's n equals 1, n equals 2, n equals 3, n equals 4. N is equal to 4 is further out than n is equal to 3. It's the next energy shell out. Part D, we have cadmium, and cadmium is number 48. It is right here. So the previous one is going to be krypton, be 36. Again, you can't do 54 because 54 is greater, and it has to be a noble gas. So we have krypton that contains those 36, so we have to get those other 12 in there. So the next row down, we have krypton is in the 4th row. So we are starting at 5 here, 5s2. Then, remember, these are one less. So this is 3 and 4. 4d. And actually, we're going to use 10 because if we look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we are in the 10th row of the D block. Again, I have seen people say 4d10, 5s2 to put it in order numerically of what the energy levels are rather than what alphabet dictates. Okay, so we can do the long version. 1s2, 2s2. We're going to follow that row down. 2p6. Then 3s2. 3p6. 4s2. 3d10. 4p6, 5s2, then 4d10 will take us there because we have 10, 20, 30, 36, 38, and 48. Now, krypton is 36. So here's 10, 20, here's 10, 20, 30. Here's your other 6. Here is your krypton. All right, part E, uranium. We're getting a little bit bigger here. We're going into the F blocks even. Uranium is all the way down here. Now remember, if this starts at 3, these start at 4. Okay. So we are looking for 92. The previous one to 92 would be 86. That would be radon. Oopsie. So radon is here. The next level is 7s2. And then after that, we skip down to the F block down here. And it would be 1, 2, 3, 4, 5F4. We can rearrange this, or we can do the long version. It's going to take a long time. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Then we have 4f. Wait a minute, I skipped a row. 4f14. No, I didn't. Then 5d10. Then 6p6. Then we have 7s2. Right here is where radon ends. And then we have 5 more that we need. So that'd be 5F4. The last one for this is lead. Lead is right here. The previous one is xenon, 54. So we're going to put Xe for xenon. Okay, xenon is in this row, row 5. Then we have 6s2. Then we can't forget about these down here for F14. Remember that these start at energy level 3. The F start on energy level 4. Then we go back. Then we go back down to D10. So this is 5D10. Remember, it's going to be 1 less 3, 4, 5th row here, 5D10. Then as we're looking at this is only 2 spots over in the 6th row of the P block. So 6P2. Again, I have seen this say for F14, 5D10, 6S2, 6P, whoops, that's supposed to be a 2. 6P2. I'm just messing up all my numbers, aren't I? I'm doing too many things at once, I think. 6p2. There you go. All right. And that's just because they're putting in order of where the energy levels are. Let's do it the long version. 1s2, 2s2, 2p6, 1, 2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Let's see, we have 10, 20, 30, 38 here. We're trying to get to 82. We are at 5s2, 4d10, 5p6. So that's 48 and 54. 6s2, 4f14, 5d10. Let's take a count now. 56, 70, 80. We only need two more. 6p2. And that lines up with what we have written up on the top. Again, this is where xenon ends. Okay, so that's all for question 75. That was a long question, I realize. But the next two aren't that bad. Question 77. Identify the specific element that corresponds with each of the following electron configurations and indicate the number of unpaired electrons in each. Okay, so 1s2, 2s2. That would be 4 electrons, which would be beryllium. So this is Be. Now, when they're talking about unpaired electrons, they're talking about if I were to write these lines, the boxes. So 1s2 goes like this. Those are the 2 electrons with 1s2. 2s2, this is the 1s orbital. This is the 2s orbital. There's 2 electrons in the 2s orbital. If it was p, it would have 3 lines. If it's d, it has 5 lines. It corresponds to how many orbitals there are. Remember, there's 2 electrons per orbital. But either way, there are no unpaired electrons in beryllium. If I look at letter B, we have 2, 4, and 4 more. We have 8 electrons. So we're looking for the atom with 8 electrons. That's right here. That's oxygen. So we have